the review for solving polynomials, the pre-assessment. So we are looking for the solutions to this polynomial. The nice thing about this is that it's been factored already, meaning it's taken an addition and subtraction problem and it's converted it to a product of two numbers, two unknowns, that equals 0. And we're going to use the 0 property of multiplication, knowing that if the product of two numbers equals 0, we know that one of these, which I call boxes, must be 0, because that's the only way you can get 0 through a product. It's either the 0 is going to be located in this box, this box, or the 0 is going to come from this box. So the question we ask is, what value for b would make this box equal to 0? So the easiest, most convenient, and systematic way is to set each of those boxes equal to 0 and solve for the b. So we're going to add 2. So when b is equal to 2, it would make this box equal to 0. And then we'll add 4. And we get 4/3. So those are my two values. If you have 4/3, would make that box equal to 0, and it would produce the 0 value. So those are called solutions. Those are the two solutions for this polynomial. And when we write our solutions, we write them in a solution set, and we're going to put them in numerical order. 4/3 is smaller than 2. 4/3 is 1 1/3. So we would put the 4/3 first and then the 2. So we like when these polynomials have already been factored, because I've already killed my pen. My pen is dead. It typically doesn't happen when I do videos, but why not set each quantity. This is a quantity of 2k plus 3, the quantity of k plus 2. You set each quantity equal to 0, because we're saying the 0 will come from here or here. One of them must be 0 in order to get a product that is equal to 0. So we will, this is a two-step problem. We will solve for the variable. Very simple at this point in math. This should take you no time at all. You're going to subtract 2, and you get k equals -2. So these are your two solutions. You're going to put them in numerical order. The smallest, or the one that is most left on the number line. So -2 is more left than -3/2. -3/2 is equivalent to -1 1/2. So that's going to be to the right of -2. X minus 4 equals 0. X minus 2 equals 0. We're going to do the inverse operation in order to isolate the variable. The inverse of subtracting 2 is adding 2. And we get, our solutions are 2 and 4. And we're going to use those solution set notation in order to show what the answers are. 7x minus 8 equals 0. 3x plus 1 equals 0. Add 8. 7x equals 8. Divide by 7. And we get x equals 8/7. Minus 1 minus 1. 3x equals -1. Divide by 3. Divide by 3. X equals -1/3. We're going to write -1/3, comma 8/7. And we're going to leave them in improper fractions. It's just easier. We don't have to convert them to mixed numbers. 3k plus 2 equals 0. 2k plus 1 equals 0. Subtract 2. we get 3k equals negative 2 divided by 3. K equals negative 2/3 minus 1 minus 1. 2k equals negative 1/2. Sorry, not negative 1/2. I'm already doing the math. Divide by 2, divide by 2. K equals negative 1/2. This is a good one. This is a good fraction question. Is which one is more left? Negative 2/3 is more left than negative 1/2. Now we get a problem where it's addition and subtraction. So our goal is to factor this. It's to turn it into the product of two numbers. And we do that by going through our hierarchy. First, is it set equal to 0? Yes, it is. Let's see. Number 1b, is it in standard form? Yep, it's in standard form. You have n to the second, n to the first, and no n. So that would be standard form. Problem 2, is there a common factor? There is no number, no coefficient, 1, 3, negative 40. No factor that goes into any of those numbers. And then you're again looking at the variables. There's no variable that all three terms have in common. So there's no common factor here. 3 is going to be special case. Special case, binomial square or difference of squares. And we know that both of those have a first and third perfect square as one of their criteria. Binomial square has 4 criteria, difference of square has 3 criteria, and they both share this as one of their criteria. So is the first and third a perfect square? Well, we would immediately look at the third, and we see that 40 is not a perfect square. No number times itself equals 40, or negative 40 for that case. So we know that since it doesn't have a perfect square as the third term, we know that it cannot be a binomial square or the difference of square. So we're going to move to technique 4, which is a times c. My a value is 1, my c value is negative 40, and we're going to take factors of 40, which are 1 and 40, 2 and 20, that's a horrible 20, 3 no, 4 and 10, 5 and 8. We look here, my signs, I look at this sign in front of my third term. It is negative, so that tells me that the signs are different. When that sign is negative, we know the signs are going to be different. And then we come here and we know that the bigger is going to be positive. So the bigger of the two factor pairs, 40 is bigger, and it's going to get the positive sign. So the bigger of these two, 4 and 10, 5 and 8, the pairs, and we know the signs are going to be different, so we see that the right side is positive, so the left side would be negative. That shows me that the signs are different. We got 39, we have 18, we have 6, and we have 3. And I'm going to look and see my middle is 3, so I look at which sum is equal to my middle, and I'm going to use these negative 5 and positive 8 as my outside and inside. I'm going to change this value. I'm going to write n squared, I think it's minus 5, minus 5n plus 8n minus 40 equals 0. If we look at negative 5n and positive 8n, it produces my middle, so I haven't changed the equation. I've just split those values to make my outside and inside. And now I'm going to factor by grouping. I'm going to group the first two, and I'm going to find a GCF of n squared and negative 5n. That GCF is going to be n. Both of those terms have an n. I'm going to factor out, and I get n minus 5. Then I'm going to look at the second grouping, 8n and negative 40, and I'm going to look for a GCF again. What number or variable goes into 8n and negative 40? Well, a positive 8 goes into both of those, and that leaves me with n minus 5. I'm going to check again. I'm going to do quick. N times n is n squared. N times negative 5 is negative 5n. 8 times n is 8n. 8 times negative 5 is negative 40. It's a nice little quick check to make sure that what I'm doing is correct, that the work that I'm writing makes sense mathematically, and it's a nice check. The other check that I'm going to utilize is these parentheses better be the same. They must be the same in order to pull that out. I'm going to pull out the n minus 5, and I see that I'm left with n plus 8. And that is how we factor using a times c. Now this problem looks like the problems that we were working here. The product of two numbers, two quantities that equal 0. We're going to set each one equal to 0 in order to find out what that n value would make that quantity 0. We're going to add 5. We get n equals 5. We're going to subtract 8. And we get n equals negative 8. So my solution set is negative 8, 5. Those are the two values. If I plug them back in, makes this equation true. The left side would be equal to the right side. So if I plug in 5, you get 25 plus 15 minus 40 equals 0. 25 plus 15 is 40. 40 minus 40 is 0, and 0 equals 0. So that's my check. So all I've done there is check to see if that solution makes that equation correct. And it does. And that would also be the case for negative 5 if I plugged it in. Or 8, negative 8, sorry, that was the other solution. Okay, so I'm going to start with 1a. Is it set equal to 0? Yep. Is it in standard form? Yes. Is there a common factor? Nope. Is it a special case? Nope, 30 is not a perfect square. So I'm going to do a times c. A times c, 1 times 30 is 30. We get 1 and 30, 2 and 15, 3 and 10, 5 and 6. Signs are the same. When this sign is positive, it means that the signs are going to be the same. And I look here and both are positive. So I'm going to do positive, positive for each of those factor pairs. I get 31, 17, 13, and 11. And my middle equals 11. I'm going to take these two terms. I'm going to split that 11n into those two factor pairs. And now I'm going to factor by grouping. I'm going to factor out an n, and I get n plus 5. I'm going to factor out a 6, and I get n plus 5. I did it correct. N plus 5 is in both of those. And if I pull it out, I'm left with n plus 6. I'm going to set each one equal to 0 again. I'm going to subtract 5. I get n equals negative 5. I'm going to subtract 6. And I get n equals negative 6. And I'm going to put my solutions in numeric order. Negative 6, comma negative 5. I'm going to look at 8. Let's draw a little line here. 1a, set equal to 0, yes. 1b, standard form, yes. 2, common factor, no. 3, special case, no. 14 is not a perfect square. A times c. 1 times 14 is 14. 1 and 14, 2 and 7. Signs are the same. Both are negative. My middle is negative 9. And we get that. So we'll make it m squared minus 2m minus 7m plus 14 equals 0. Now be careful of this. We again check real quick. Negative 2m and negative 7m makes my starting middle term. So I know I did that correct. So when I factor by grouping, this one's pretty straightforward. I'm going to factor out an m. And I get m minus 2. Here's the one place that students will make a mistake. When your first term is negative, you must factor out a negative. So I'm going to factor out a negative 7, and I get m minus 2. Many students would do m plus 2. But if you're taking the time to check, Negative 7 times m gives you your negative 7m. Negative 7 times positive 2 would tell you that that equals negative 14, and you don't have a negative 14. So there would be the place where you would say, oh, I made a mistake there. That shouldn't be a positive 2. It should actually be a negative 2, because negative 7 times negative 2 gives me my positive 14. So be careful. The other thing is, remember, these have to be the same. So of course this has to be m minus 2. Since they are the same, we can factor that out, and you're left with m minus 7 equals 0. So these are places that students, where I see students typically make their mistake, because they're not thinking about the problem logically, and they're not looking and testing and making sure what you write is what you get. You should know it mathematically. You should take a peek and make sure that whatever you're doing, whatever step or whatever you're writing, makes sense mathematically. Yes, set equal to 0. Yes, in standard form. No common factor. Not a special case, not a perfect square. 6 is not a perfect square, or negative 6 is not a perfect square. So we're going to do a times c. 1 times negative 6 is negative 6. We have 1 and 6, 2 and 3. You say, hey, why aren't we taking factors of negative 6? Well, because we're going to do the factors first, and then we're going to put the number or the signs in there. So it'll eventually equal negative 6. These products of these factor pairs will eventually equal, but we have to look and see which one is assigned to which. Because when we get a negative, we know the signs have to be different, and the bigger is going to get the positive, opposed to, right? So this, what's negative 1 times positive 6? That's negative 6. We could have had this. We could have had positive 1 and negative 6. That makes the product of those two numbers, but notice the sum equals negative 5. Or the sum equals negative 1. Well, that wouldn't equal my middle. So that's why it's very important that we assign these signs and we read this information, these tea leaves. Negative means that the signs are different, because this number is produced through a product. And then we look here, and this is my outside and inside. This is the sum of my outside and inside, and that tells me I have more positives than negatives. So the bigger has to be positive, the smaller has to be negative, and this is equal to my middle. So that's the logic that we're talking about. If you understand this, the better, and not only the better will you do better on your assessment, but your recollection and your recall and your retention is the word I was looking for, will be a whole lot better. So if you know it for the logical reasons, you tend to be able to recall it better. I'm going to separate each one, set it equal to 0, because one of them has to be equal to 0. So we add 2, we get b equals 2. We subtract 3. B equals negative 3. So my solution set is negative 3, positive 2. We're still with setting it equal to 0. That's a big yes. Standard form, yep. Common factor, nope. Perfect square, special case, none of them, neither are perfect. Well, 3 is not a perfect square. And a times c, 1 times 3, which equals 3. And my factors of 3 are only 1 and 3. Signs are the same and both are positive. We get 4, that's equal to my middle. We're going to take those two terms and substitute it for my outside and inside. We're going to group. I'm going to factor out a k. This is a fun one. Factor out a k, you get k plus 1. That's very important that you hold that placeholder. And we're going to factor by grouping. We're going to factor out a positive 3. Make sure you have that sign there. and you get k plus 1 equals 0. K plus 1 times the quantity k plus 3 equals 0. We're going to set each one equal to 0. K plus 1 equals 0. K plus 3 equals 0. Subtract 1. Subtract 3. And my solution is -3, -1. Numerical order. Ooh, here we go. All right, a little change up. Remember 1a is set equal to 0. Is it equal to 0? No, it's equal to -6. So we have to set that equal to 0. This has to be 0 on the right side. So what's going to get rid of a -6? Well, +6. So I'm going to add 6. Whenever I do to one side, I'm going to do to the other. We have to balance the equal sign. So if I add 6 to the right, I got to add 6 to the left. And I chose to add that other 6 next to its like term. It's a constant, so I'm going to put it next to the constant. So I get x squared plus 2x minus 35 equals 0. And now it's equal to 0. Boom. Now I can move on. When I rewrote it, did I write it in standard form? X to the second, x to the first, and no x value, constant. So it's in standard form now. Is there a common factor? Nope, no number and no variable. Is it a special case? -35 is not a perfect square. So I'm going to utilize a times c. A being 1, c being -35. Factors of -35, 1 and 35, 3 no, 4 no, 5 and 7. That's a nice one. Signs are different. Bigger is positive. That gives me 34. This gives me 2. And yes, we notice again that the computer produces that last pairing. Not going to be the case during the assessment. So those of you that are taking the time to make it this far on the video or are watching the video will know that we will definitely not be using the last one every time. So we're going to factor out an x. We get x minus 5. We're going to factor out a 7. We get x minus 5 equals 0. X minus 5, x plus 7 equals 0. Set them each equal to 0. Add 5 minus 7. My solutions must be in numerical order. How many times have I said that? A lot. All right, again, set equal to 0. Nope. So this time we're actually going to subtract 6. N squared minus 7n plus 6 equals 0. Now it's set equal to 0. It's in standard form. No common factor. No special case. 6 is not a perfect square. A times c. A is 1, c is 6. Factors of 6, 1 and 6, 2 and 3. Signs are the same, both negative. Hey, we didn't use the last one. Yay! That's equal to my middle. So these are my factor pairs. I'm going to write n squared minus n minus 6n plus 6 equals 0. I'm going to factor out an n to get n minus 1. I'm going to factor out a -6. Make sure there's a negative there. And I get n minus 1 equals 0. N minus 1 times the quantity n minus 6 equals 0. Set each one equal to 0. N minus 1 equals 0. n minus 6 equals 0. Add 1. Add 6. 1 comma 6 is my solution. Doing a page per problem makes it easier, gives me a little bit more room. Not equal to 0. Let's add 4 to both sides. Notice I'm lining them up to its like term, if there is a like term. Now it's set equal to 0. It's in standard form. There is no common factor. Not yet. It is not a special case. 14 is not a perfect square. So I'm going to do A times C. 1 and 14 is 14. Factors of 14, 1 and 14. 2 and 7, signs are the same. Both are negative. Negative 15, negative 9. We're back to the last factor pairs as being my solution. R squared minus 2r minus 7r plus 14 equals 0. Remember, negative 2 and negative 7 come from these factor pairs. They're not coming out of just nowhere. Those are specifically written because negative 2r and negative 7r also add up to negative 9, and when they multiply, they make positive 14. There's a system here. There's a riddle, a reason to the rhyme. Factor out an r, r minus 2. Factor out a negative 7. R minus 2 equals 0. R minus 2, R minus 7 equals 0. Are you doing the problems this fast and efficient? I hope you are at this time. It's going to be very impressive to see those students who are, oh baby, almost got ahead of myself. Got over my skis. Make sure that you don't go so fast that you make a mistake. Mr. Mack almost went so fast that he made a silly mistake. So I'm going to look. I felt like I did something wrong, but I'm going to check my work. It looks okay. It only takes a second to check your work. It's huge value. So set equal to 0. Not equal to 0. Let's add 3. Add 3. R squared minus 5r plus 6 equals 0. Oh, we added the number together. Ooh, I wonder if that's going to make a perfect square. So now it's set equal to 0. It is in standard form. 2 is common factor. No common factor. Special case. Ooh, now I'm going to check. Oh, perfect square. Yeah, I added 3 and 3. Does that make a perfect square? Is 6? No, don't confuse adding two like numbers and multiplying two like numbers. 6 is not a perfect square. No number times itself gives you 6. So this is not a special case either. Be aware. Understand completely what is being asked of you. If you don't, you're going to make weird and silly mistakes. Signs are the same. Both are negative. Negative 7, negative 5. This is my middle. Negative 2 and negative 3. Negative 2r, negative 3r plus 6 equals 0. Now factor out an r, r minus 2. Factor out a negative 3. R minus 2 equals 0. R minus 2, R minus 3 equals 0. R minus 2 equals 0. R minus 3 equals 0. Add 2. Add 3. And we get 2 and 3. Yes. Okay. Oh my goodness. Look at this one. Hello. How cool is this problem going to be? Let's set it equal to 0. Let's add 4. You get m squared plus m. Negative 4 and positive 4 makes 0 equals 0. Whoa! Now it's set equal to 0. Is it in standard form? Yes. It's set equal to 0 and it's in standard form. Man, I love this problem. Is there a common factor? Yes. What is the GCF of both of those terms? The GCF, they both have an m. So we can factor out an m, and that gives us m plus 1. Now, a lot of students would continue on and go, oh, let's see if it's a special case. Let's do a times c. We don't have to. We're done. We're done here. You're done in the sense you don't have your solutions, but you're done factoring, because remember, factoring is turning addition and subtraction into multiplication. We have multiplication of two things. We have two boxes when multiplied equals 0. So one of these two must equal 0. So we're going to do what we did in this. We have the product of two things that equals 0. So we're going to set each one equal to 0. Well, that's it. What makes this box 0 is if m equals 0. What box makes this m, or this box, what value for m makes this box? Well, now we have to solve it. We do have to isolate. So -1 would make this equal to 0. So that's why that's a solution. So my solutions are -1 and 0. Such a good problem. So happy this is on there. 15 is my favorite one so far. Oh, I like this one too. We're getting into some good different types of problems. And the reason why I like this is because it's not set equal to 0. So we got to move this. We got to get rid of the -10m, adding 10m. But where do you put it on the left side? Well, it's not a like term to m squared, and it's not a like term to the constant. So we put it in between those two because we want to write it in standard form. And standard form is in descending order based upon its variable. It's alphabetical variable if you have multiple variables, alphabetical. And then if you have the same variable, you do it in descending order. The one with the highest exponent, m to the second, and then m to the first, and then no m value. So your constant's always going to go last. And now it looks like your regular problem where it's set equal to 0. So it's in standard form, and I set it equal to 0. It's now in standard form. It doesn't have a common factor. It's not a special case. 24 is not a perfect square. So we're going to try technique 4, which is a times c. A is not a is 1. C is 24. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And by this time, you better know your factor pairs of at least up to 100. You should know them pretty quickly and easily. Signs are the same. Both are positive. And we're looking to see which sum, which sum is equal to my middle. And no shock to any of my students knowing that on the homework, this computer, when generated by this program that makes these problems, it tends to be the last two pairings. But do not get lulled to sleep in thinking that that's going to be the case always, just when I forget. M plus 4, M plus 6. Set each one. M plus 4 equals 0. M plus 6 equals 0. And for all you shortcutters, be careful because we are getting to the point soon where we can't just use our factor pairs as the solutions and do the opposite. That is not always going to be the case either. There's a couple things you have to be careful about in lulling yourself into a pattern, seeing a pattern that does or doesn't continue. If it continues for all of them, you still have to be careful. Know what you're doing. Know why you're doing it. make sure that you're taking the time to do it right. There's no rush here. Standard form. You're not going anywhere. It's better to take your time and do the work properly. 24 is not a perfect square. Negative 24 is not a perfect square either. A times C, 1 times negative 24 equals negative 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Again, signs are different, and bigger is negative. I was really hoping it wasn't the bottom one. But it is. We're getting there. It'll be there. I promise. I know it's coming. We're going to factor out an x. We get x plus 4. We're going to factor out a negative 6. We get x plus 4. X plus 4. X minus 6. Set them equal. X plus 4 equals 0. X minus 6 equals 0. Minus 4 minus 4. Plus 6 plus 6. Negative 4 and positive 6. All right, 18. We're still going. Set equal to 0. We're going to add 3x. Make sure that it doesn't have a like partner. It doesn't have a like pair. That is not like terms, and that is not like terms. This is x to the first. This is x to the second. So those are not like terms. You cannot combine those. So you're just going to rewrite it in standard form. Standard form, common factor, special case, 18. Nope, not a perfect square. A times C, 1 and negative 18, negative 18. 1 and 18, 2 and 9, 3 and 6. And that's it. Signs are different. Bigger is positive. Negative 3. Oh, I rue the day. SAT word. I rue the day that it doesn't end up being the last factor pairs. Can't wait. I'm going to be so excited when that is the case. X minus 3, x plus 6 equals 0. X minus 3 equals 0. X plus 6 equals 0. Add 3, add 3. Minus 6, minus 6. Negative 6, 3 are my solutions. Okay. Set equal to 0. We're going to minus 7n. N squared minus 7n plus 12 equals 0. 1a, 1b. Common factor. Special case. A times C. 1 and 12. 2 and 6. 3 and 4. Signs are the same, both negative. N squared minus 3n minus 4n plus 12 equals 0. Factor out an n, n minus 3. Factor out a negative 4, n minus 3. N minus 3, n minus 4 equals 0. Here's a time, we didn't talk about this yet. Here's a time where we can check our work by multiplying that back out. Do the FOIL, first, outer, inner, last. Do the double distribution. Do you end up with n squared minus 7n plus 12? Yeah, because that's my starting problem. So that could be a check also. So not only can you check your solution, which you should take the time to do, but you can also check your factor pair, or your factors, your two binomials. Let's set them equal to 0. to find out what values for n make that box equal to 0. So when n is 3, it makes this box equal to 0. When n is equal to 4, it makes this box equal to 0. So my solutions are 3 and 4. That only happens, you can only do that when it equals 0, because no other number, no other value, no other product has that quality. That quality of one of them must be 0. If it was two numbers that equal 8, we have no idea. There's an infinite number of numbers that can go in there. And none of them every single time will be the same. In here, every single time, one of those two numbers must be 0. Ooh, I like this one. This one's a little crazy. Let's set it equal to 0. Let's subtract 7m. We get m squared minus 7m equals 0. It's in standard form now. However, this time we have a common factor. That common factor is m, GCF. So we're going to factor out an m. We get m minus 7. We are done because we have the product of two things that equals 0. So we're going to set each one equal to 0 and find out what value for m makes it 0. Well, m equals 0. We'll add 7, and we get m equals 7. So my solutions are 0 and 7. All right, now we're going to get interesting. Now we've made problems 21 through 25 get fun. Set equal to 0. Okay, we can do that. That's easy. 45a squared minus 12a minus 9 equals 0. It's in standard form. And now, common factor. Ooh, there is a common factor. So what number goes into 45, negative 12, and negative 9? The GCF of that is going to be 3. So I'm going to factor out a 3 from those. I get, not 9, hello. I get 15a squared minus 4a minus 3 equals 0. Okay, is it still in standard form? So I'm going to go back to, is it equal to 0? Yes, but with no first. Now yes. Was it in standard form? Yes. Then I had to take out a common factor, and I go back to standard form. Is this in standard form? That has to be in standard form also. It needs to continue. So second time, common factor amongst these. This isn't a bad place to double check. Make sure you took out the GCF. So there still is no, there is nothing. Okay. Now I'm going to move on to special case. 3 is not a perfect square. And now I'm going to do a times c. My a is going to be the coefficient of a squared, which is 15. And my c is still going to be the constant, negative 3, which gives me negative 45. Factors of 45, 1 and 45, 2 no, 3 yes, and 15. We had those numbers right there. 4 no, 5 yes, 5 and 9, 6 no, 7, 8, and then we're back around. Signs are different. Bigger is negative. Signs have to be different, so you'll have one that is positive, one is negative. Here I thought it was going to be, trust me, I'm going to make it on purpose, not the bottom. So we have 3. Now we're going to change our middle. We're just doing the same thing. That 3 is just going to sit outside there. Plus 5a minus 9a minus 3. Where did I get those two numbers from? From my factor pairs. We're still going to factor by grouping. So the 3 stays out there. And we're going to factor out a 5a. It's getting a little bit more complex. You have to slow down and make sure that you're taking out the GCF of these two terms. So not only is it a variable, but it's also a coefficient. 5 goes into 15 and 5, and a goes into a squared and a. If I take that out, I get 3a plus 1. Check it. Multiply it back out. 5a times 3a equals 15a squared. 5a times 1 is 5a. take a second and just make sure. And we look at our other pairing, I'm going to take out a -3. First term is negative, so you better factor out a negative. And we get 3a plus 1 equals 0. Okay, I know I did it right because it's 3a plus 1. Don't forget that 3. 3a plus 1, 5a minus 3. Wow, we got much more complex right there. So when we see this, we have 3 times a box equals 0. We know that one of those 3 has to be 0. Well, we know that that can't be the one that's 0 because it's equal to 3. It's a constant. That is not where the 0 is going to come from. We just have 3 numbers multiplying that make 0. That 0 is going to come from wherever the variable is. Variables, the quantities with variables are the ones that are going to have the opportunity of being 0. If it's a constant, it can't be 0 because it's this value, it's 3. So this goes by the wayside. We're still going to set each quantity equal to 0, and we're going to solve. So now we have two-stepped, much like our first 5 problems that we started on in this practice. So we have -1/3 plus 3, 5a equals 3, divide by 5, and we have 3/5. So my two solutions, -1/3 and 3/5. All right, definitely more complex. Oh, another good one. I love it when there's only 2. Set it equal to 0. We're going to add 8x. That gives us 6x squared plus 8x equals 0. It's in standard form. There is a common factor, the GCF. Don't just think variables, look, numbers and variables is 2x. We're going to factor out a 2x. You get 3x plus 4 equals 0. You have the product of 2 numbers that equals 0, so set each one equal to 0. Divide by 2, x equals 0, minus 4, 3x equals -4, divide by 3, divide by 3, x equals -4/3. -4/3 is smaller than 0. It's more to the left on the number line. Ooh, okay. Now we have 2 things. A lot of people, we always want, whenever we write our equation in standard form, this first term, our x squared, or whatever our first term, must always be positive. It's not always going to be x squared either. We're going to do cubed and all these other crazier ones. But so in this instance, instead of subtracting 10v squared and moving over where more of them are, that would make -10v squared plus 25v plus 125. My first term would not be positive. So we don't want to be moving the 10v over. We actually want to move the 25v over and the 125. So we would be subtracting 25 and subtracting 125. Those, all 3 of them, are unlike terms, so we wouldn't be combining them. We would be writing them in standard form. And now we look for a common factor. Set equal to 0. Standard form. Common factor, yes. Doesn't have a variable, but it does have a 5, so we can factor out a 5. That gives me 2v squared minus 5v minus, what's that, 25 equals 0. Do a quick check. Make sure that there's no common factor that's still able to be pulled out of those. So that just takes a second to check your work. Ooh, oh, look at that, special case. Oh my goodness, that is a perfect square. Actually, it's not. No number times itself equals -25. So we know all perfect squares must be positive. And our first wasn't a perfect square either. 2 is not a perfect square. No number times itself equals 2. So not a special case. kind of teased you there, almost a times c, which is 2 times negative 25, which is negative 50. Factors are 1 and 50, 2 and 25, 3 no, 4 no, 5 and 10, 6, 7, 8. Signs are different. Bigger is negative. Drats. Maybe someday it won't be the bottom pair. 5, 2v squared plus 5v minus 10v minus 25 equals 0. Factor by grouping. Factor out. Ooh, no coefficient. A lot of oohs in this video. No coefficient, but a variable. So we can only take out a v, and that gives us 2v times 5. Factor out here, we can take out a negative 5, which gives us 2v plus 5 equals 0. We get 5, 2v plus 5, v minus 5. That's a constant. This can't be the 0, but since they have variables, we're going to set each one equal to 0 to see what that variable would need to be in order to make that expression or that quantity equal to 0. Negative 5 halves and 5. Negative 5 halves and 5. All right, we're getting there. 2 more. Oh, I like this. Look at that. That's nice. It's already set equal to 0. 1a, 1b. It's already in standard form. Common factor. Yes, there's a GCF, which is 3x. Let's take that 3x out, and we get 5x plus 1 equals 0. Set equal to 0 because we have a product of 2 quantities that equals 0. When x is 0, it makes that number 0. 5x negative 1 divided by 5. X equals negative 1/5. Numerical order. And last but not least, let's set it equal to 0. Oh, almost made a mistake. Take your time. Make sure you're doing it correctly. We didn't have a single binomial square or difference of square. So check your homework, because I will let you know, again, if you've made it this far in the video, you get a special hint. There will be difference of squares and a binomial square problem. If you want to see what that looks like, look at the homework earlier in last week. We're going to factor out 12, 16, and 16. 4 goes into each of those. We get 3x squared. We get plus 4x minus 4 equals 0. Not a perfect square, even though this is a perfect square. This is not, so we know it's not a binomial square. So we're going to do 3 times negative 4 is negative 12. 1 and 12, 2 and 6, 3 and 4. Oh, look at this. Signs are different. Bigger is positive. Save the best for last. There's an example where it's not the bottom 2. Yay. 3x squared. Let's change my middle to my factor pairs. My outside and inside end up being negative 2x and positive 6x. We're going to factor by grouping. We're going to factor out just an x. We get 3x minus 2. We're going to factor out a positive 2. We get 3x minus 2 equals 0. 4 times 3x minus 2 times the quantity x plus 2. That 4 is just coming along for the ride. It's been factored out because it needs to, all of this, we multiplied it back out, needs to equal this starting problem, needs to equal that. So it needs to come along for the ride, even though it's not part of the solution. But you want to be able to make sure that when the teacher looks at your work, that it makes sense mathematically. You're defending your solution. The only way you can defend your solution is by showing your work. Showing your work is going to be extremely beneficial because we don't always make the proper, we don't always do problems correctly. So when we go back, do we have the ability to look at our work and make sure that we did it correctly? Good luck tomorrow. I know you'll do well. I'm excited for you to take this assessment.